Okay. Right. I think we're good to go. Function arguments. I actually don't know how to approach this one. It's a bit loud. Okay. So let's just dig in. Let's start the section with a little recap. In Monkey, we can define functions to have parameters like this. Excuse me. Got 3 parameters. Yep. When we call it, we use the arguments in the call expression. Yep. Excuse me. This binds the values passed in as arguments to the parameter names while the function executes. Now, the bind should ring a bell. I don't want to beat around the bush, so let me come straight out with it. Arguments to function calls are a special case of local bindings. That was my guess last time. So that means when we save the space in the stack for local values, we've got to add some for the arguments too. Just gonna quickly, this seems a bit too zoomed in. AST, yeah, AST function literal. Okay, we can just do length of parameters. Yeah, that could work. Nope, wrong tab. They have the same lifespan, the same scope, they resolve in the same way. Okay, yeah, they make total sense. The only difference is their creation. Excuse me. The only difference is their creation. Local bindings are created explicitly by the user with a let statement, and the result in offset local instructions being emitted by the compiler. Right. Arguments, on the other hand, are implicitly bound to names. This is done behind the scenes by the compiler and the VM. Yeah, that could be a problem. We could just manufacture some lets. Our goal in this section is to fully implement function parameters and arguments to function calls. At the end, we want to compile and execute this snippet of monkey code. Let's go to global, 2 parameters, you add to global. Okay, out is another function. Excuse me. Yeah, okay, so it tests most of everything. Compiling calls with arguments. Yes, I'm still sleepy. The condensed version of our current calling convention is this. Push the function you want to call onto the stack, emit opcall, and off you go. The question we're now facing is where to put the arguments to the function call. Not only where in the sense of memory location, but also where in the calling convention. We don't have to search for a memory location for too long because we already have a place. Yeah, exactly. Memory is straightforward. And just like we use the stacks to store, but there is one problem. Accessing these. So they either go, they would go before local bindings. You can use it to store the arguments to the call. Why after? Oh yeah, because the others have an index. Okay. I mean, yeah, it has to be after. Because all the local bindings have an index. Right. I mean, they only have an index because we set it. Yeah, I guess it makes sense. So if we adopt this approach, it changes our calling convention to this. Push the function you want to call on the stack, then push all the arguments to the call onto the stack, emit opcall, and off you go. The stack would then look like this right before executing opcall. Okay, if there's no local scoped arguments. Oh, like variables, sorry. As things stand though, the solution poses a slight problem to our VM, because it wouldn't know how many arguments are on top of the stack. Either have to reuse one of the existing opcodes or maybe create a new one. Think about implementation of opcall in the VM. Before we push the new frame, we take the function to be called right up the top of the stack. With this new calling convention, there could be 0 or multiple arguments on the stack on top of the function. How do we reach the function on the stack so we can execute it? Take the function to be called right off the top of the stack. In this new calling convention, there could be 0 or multiple arguments on the stack. Yeah, before you execute anything else, function comes off the stack. Interesting. Yeah. How do we reach the function on the stack so we can execute it? These functions are ordinary monkey objects. We can't even choose a hacky way. I mean, we can do it in Zig because you know what the tag name is. Yeah, but I don't like this idea. That might just be an argument to the function call. There's a simple and beautiful solution available. We call the opcall opcode. We give the opcall, jeez, can't speak this morning. Yep, we give the opcall opcode an operand that holds the number of arguments of the call. 1 byte is enough for that. What does opcall take as an operand? Okay, nothing. Okay, makes sense. So you add a single operand, and when you compile, you add the number of arguments. How do you execute it still? Do you pop those many things off? This changed some tests, yeah, obviously, because we defined oh fuck, there's gonna be like a few tests to update. It's fine. Boom. That makes the compiler test correct. Yep. Yep. Yeah. It's worth noting that the function used in these new test cases have an empty body and don't make use of their parameters. That's by design. You first want to make sure that we can compile function calls. I swear it sounds a bit strange. Not the book, but I mean, I sound strange through the mic. Weird. Weird. Right, we first want to make sure we can compile function calls, and once we have that in place, we'll reference the parameters in the same test and update our expectations. I'm curious about how these would get added to the stack. What happens during opcall? ST call expression. Okay, you do have an array of expressions. Okay. I mean, so far we've only added the operand. The missing up constant. Yeah, obviously, because we added an operand. What's the test again? Interesting. Where's the input? Here. Excuse me. I'm still not fully sure how this is supposed to work. Because the constant here will be added. Okay, you get the constant of the stack. And you compile when you run opcall. And you know how many. Oh no, you add it to the stack from the constant. I swear, every time I sort of forget how it works. It comes back after a few minutes though. totally distracted. Interesting. Excuse me. Yep, function itself and 3 constants. That makes sense. Kinda makes sense. Okay, move on. Moving on for now. What's missing? Constant 0. Set global. Get global. Up call. Up. Constant 1. I guess this is the argument. Yeah, right before call. Missing op constant instructions tell us that we need to compile the arguments of the function. And the wrong operand of opcall tells us that it's still unused. Opcall is 0. Expected 1. Yeah, because I think we didn't update the compiler. Well, my guess is you look at the argument past the length. Yeah, easy. Easy peasy. I can see the value of creating a syntax tree. As one of the steps. Makes things a lot more easier. What hasn't changed here is the compilation of node.function. I mean, I say that because it's not really obvious to construct a syntax tree first. Whoever figured it out, fucking genius. I have to say. What hasn't changed here is compilation of the node function. Yep, because the function does need to change too. We also need to push the arguments to the function call onto the stack, so we need op constants. We do that by compiling the arguments in sequence. Ah, right. I missed that step. I just assumed it's a constant, so it gets added onto the stack willy-nilly. Okay, so you gotta do that too. Right, so it'll be just above. Yeah, because function literal and then call. So when call happens. Yeah, okay, gotcha. Starting to see how this could work. Alright, let me do this much first. Where's op call? So on the stack, it should be the op constants need to be before op call. No, after. But it's last in, first out. It's a stack. Operand should be self dot. No, sorry. CE dot arguments. Yeah. Hey Leon. Why not use any of the more popular languages for the compiler? I don't know what to say. This is like more of a, what's it called? Like a fun side project. And I'm just curious about Zig. And yeah, I thought it'd be a good opportunity to get better at Zig. I guess that's why. Yeah, I would say definitely. I don't intend to create a new programming language. I've always been curious about how, like, I've wanted to know how they work, so that's also the purpose. If that makes sense. What language were you thinking, just out of curiosity? It's a bit too... Just gonna reduce the opacity. Can't read it. Gotta pull off a Teddy Davis and build an OS in Zig next. Yeah. Maybe. Something like C++, C Sharp, or Python. I did build the first time. I only built the interpreter and I built it in Go. Although, yeah, because at the time I wanted to know, I wanted to get better at Go. Pile. I guess that's it. So it would be, the stack would look like call, no, above. Oops. Constant. Yeah. Const. As opcall will be added first. But hang on. Should it be? Well, I guess. I mean, they should be above. Or maybe not. Because during execution we need to get it off. Not sure. I'll leave it as is for now. Let me add a, see if I can extend. Oh, motherfucker. Could update tests. Call. Ooh, maybe I can do search and replace. Come on. Maybe. Okay, Let me ask Cloud. .code slash okay. Well shot. Hang on. Come on. No, doesn't look right. Okay. Up call. Okay, that was not a lot. Gotta check the VM.sec. Yep. Function args is next pointer self dot stack pointer plus 1. No, don't need to set that. Let me just check offset. Yeah, I can actually check this. max int of u8. Should be instructions. E plus 1. I should fix the VM. Set. Frame.ip. Okay. We'll come back to this later. What's simple? Cool. Right. Okay. Put out a test. Guess I could extend one of the early ones. They were simpler. Yeah, let's try this one. And then 1. Where's up constant? Sorry, not up constant. Expected constant here. Then 4. 1. Constant 1. Call should have 1 argument. Okay. Does it look similar? Okay, constants do come after. Let's function first. Sorry, this one. Before, sorry. Right, sig test source compiler. Oh yeah, my bad. Object.integer. Equals 1. Expected 001. This is the first constant. And then the second constant. Okay, so this is op call with 1 argument. Okay, so the order's the other way around. Function. No. Call expression. So means this needs to be here. Guessing that should fix it. Expected true, found false. Is it constant? Yeah, I think it is the constant. One, 2, 9, 9. Yep, I think it's the test that I just added. Wonder why I didn't do testing dot equals slices. Tick dot object. Oh no, because can't check equality that way. Need to check the value. Debug print dot dot constants of I. Integer and function is the wrong function. I guess the order is different. Yep. Should be constant first. Where's my test? Yep. This should be here. Yep. Yeah, because the arguments get passed first. Okay, see if I can copy a test from the... Yeah, this one. And just call it. This one, maybe, yeah, it's fine. Or maybe not, because I got quite a few offset. Yeah, let's start from here. Comma C. So 2 comma 3. Then we need to, yeah, I think that's it. And this is the function itself. Operands should be 3. Okay. I guess that's everything. I would like to try upcall. Oh no, not here in the VM. So we know how many arguments are here. Argument count. So the stack pointer should be plus args count. Still cold now. There's 2 stages. Get args from constants. Literal. This is fine. I don't think it's necessary. Then get args from constants. On return, replace stack pointer. So this won't be the object. Sorry, this won't be the function instruction. I can test this by not that one. can use the test from early on. This one. I mean, completely unnecessary. Okay. The expected, what was the expected number? Gotta do some math. So it's 10 plus sum of 1, 2. So that's 3 plus 10, 13. And then 7 plus 10, 17. That's 30. Plus 10, 40. Oh, plus 10. It's 50. I mean, this should explode, really. Yeah. I didn't expect that test, that error. Undeclared identifier. Yep. It's complaining about the argument. That is interesting though. So somehow the symbol needs to be associated with the right something. Because if I look at here, A comma B, but A and B, if you look it up, it's not defined. So in the current frame, jeez, that was a bit loud. In the current frame, it's got to be present as well. The question is how? Not really sure. Oh yeah, actually I don't really care, because it always goes back to the base pointer. Yeah, don't need to worry about that. It's just... Alright, let me read it up. Compiling calls with arguments. Go ahead. Yeah. Hang on, I didn't update the compiler. I was jumping ahead. I didn't think there was anything else to update. If I look at the compiler call expression. Right. Constants are added. Functions added to the stack too. To the constant, sorry, not stack. Let's be sure about what we expect from the compiler. At the same time, at the time of a function call, the arguments will now sit on the stack. Will they? How do we access them while the function is executing? My question exactly. Should we add a new opcode, something like opget argument? I mean, you could, and it's fast, but it's kind of redundant because you don't need the opcall to have arguments then. Or like an operand, sorry, not arguments. Tells the VM to push the argument onto the stack. For that we would need to give the arguments their own scope. Yeah, no. Oh, they don't like the sound of that. It offers much more flexibility. In Monkey, there's no difference between arguments passed into a function and local binding, exactly. Once you look at the stack at the same time of a function call, at the time of a function call, it also becomes the obvious choice. The arguments sit right above the function that's being called, and you know what's normally stored. In this region of the stack, local bindings. So they would have to come after the local bindings. I mean, they could. Did they come before? I mean, I guess so. would depend what the compiler decides. Get local instructions for every reference to a function's parameter. Now we've got A, so we need an offset. No, we don't need to set A. If you don't set it, how do you have the definition? And why global? Oh no, that's the function, sorry. Constant 0, yep, that's the function. Constant 1, call 1. Oh sorry, yeah, I'm looking at the wrong place. Get local. What happens on offset? Okay, so this would need to happen during op call. Add it to the stack. Get local 0. Get local 0, 1 to 3. But when it has won't that mess up the index of instead of empty function bodies, we now have references to the parameters of the functions, and the updated expectations tell the compiler that these references should be turned into opt-get local instructions that load the arguments onto the stack. The indexes to these opt-get local instructions start from 0 for the first, and then increment with each next one. Yeah, exactly. If you run the test, we can't see the expected. All it takes for us to fix this is to define the parameters of a function as a local binding, and define is meant to be taken literally here. Okay, so when you come across parameters, Hmm. That's pretty neat. I'm not sure how that worked. Function literal. Oh yes, because they're identifiers. Interesting. Okay, so is that it? Arguments in the VM. So now that we have I guess now it makes sense. Not this one, sorry. Get local. Maybe. Not entirely sure how this works. Let me have a look at symbol table. Oh, it's wrong file. It's the part that I don't get. Oh yes. Identifier. I need to add it to the symbol. Then emit get local. I'm not gonna lie, I'm a bit confused. Don't even remember how the symbol table works. Totally forgot. Oh, okay. Now I remember. It's a linked list. Have to admit, not really sure. How to find? Just adds get local. Have a look at what define does. Filing local. Okay, define. I'm guessing it's the same as add. Yeah, that makes even less sense now. Question is, why would that? Okay, fuck. Cause I'm yeah, cause anytime you come across an identifier in the function body, it adds an obget. Alright, let me add the test first. Excuse me. Compiler. I don't know, I was thinking way too much. Or maybe I just forgot some of the implementation. Where's my argument? Yeah. ABC. And the function itself. Expected instructions. Yeah. Okay, local 1. Then this should be 2. That it? No, wrong. Take test source compiler. Undeclared identifier. Yep. Compiler 2. Literal. Guess it should be before it exits the scope. Oh no, yeah. Maybe even before block statement. I wonder what I'm missing. For function literal dot params. Don't remember what it was called. St parameters. Self dot symbol table dot add. Do I need the symbol? Not really. Either value. He was right. That's pretty neat. I didn't expect it to be that easy. But I think the only confusion was usually when there's a new identifier, the upset was handled by here. So I didn't have to worry about it. Okay, that's fine. Now in the virtual machine, actually, opcall. I guess that's all I need it for. That'd be so cool if it just works. Alright, here goes. Mosaic test source VM. Ah, what happened? Did I add the test? Yeah, I did. Session failure at 96. I think I know why that's happening. I don't support implicit returns, which is fine for hey, but it's pretty close. Maybe my math was wrong then. A plus B, 3 plus 10, 13. Plus 17. That's 30. That's 40. And that's 50. Okay, now my math is right. Where's it getting 34 from? Is that the only error? That's wild. I expected more errors. Is it this? I mean, yeah, there's only 150. Let me just change this to 5, see what happens. Okay. Where does it get in 34 from? Sum of 1, 2. That's 3 plus 10. 13. 7 plus 10. 17. 30. Yeah. Where's the 4 coming from? Unless... I think I might know why. What's 13 plus 13? 26, 30. No, that still doesn't make sense. Huh. I'll call. I have no idea how it's getting 34. Ooh. 17 plus 17. Unless, yeah, okay, that makes sense. Somehow it's using when I call up get local. Yeah, because it's not using the right binding. Or it's using the latest one. Makes sense. Alright. Arguments in the VM. Yeah, I don't think you need to do much here, do you? Yeah, I just added all of it. First case, we pass one argument to a function that only references its single argument and returns it. The second test case is sanity check. Hardcoding edge cases to our VM. What? Calling non-function. I never got that error. Right. I mean, they haven't showed up in a while. Fails because it can't find the function. That's because it's looking in the wrong place. Oh yeah, because you haven't updated the stack pointer. Yep. Number of arguments. Exactly. Yeah, I did that already. Calculate its position by decoding the operands, nummarks, subtracting it from... What? Oh. Hang on a minute. Interesting. Okay, that explains why I'm getting 34. Because it's somehow, I think, by sheer luck. I can add one more test. Which one did fail? I'll try this one. I think they should fail. 31. This should be 3. Yeah, okay. It's an integer. Should have just tried the simple s first. Yeah, I just got ahead of myself. 1 minus... I also realize I need... to set if self dot b greater than or equal to. Ox count plus 1. Found null. Okay, that's a different problem. That's actually quite bad. This fails silently. I know why it's failing silently. I mean, it's convenient. Don't want to mess it up. Okay. It's 1. An object should be minus ox count plus 1. Okay, so what do you get instead? Debug any object. Integer value 1. Also want to print ox count. Two. What about the stack? Oh no, that's a bad idea, because I gotta print the whole stack. Oh, maybe I can just print nah. Self dot stack 0 to self dot stack pointer. Yep, it's not very readable. Okay, stack is here, integer. What the fuck? Oh no, it's actually correct. Two, and then the function itself. So there's only three things on the stack. 1, 2, and the function itself. Right? P minus 1 minus opt count. Should be 0, which is the function. Yeah. No. Actually, that doesn't make. Because 0, 1, 2. Somehow my stack is in the wrong order. Let me check the compiler. Where's that function? Not this one. No, not this. Yeah. I mean, that makes sense. The objects get added first. I think I know why. Function literal. Because I'm adding the should get added after. When do you exit scope? That's not it either. Because that's actually correct. Where is it? Here. I have missed something somewhere. Can't remember what. Yeah. Parameters do get compiled first. Test term failed because VM can't find the arguments on the stack. Fails because it can't find the function. That makes no sense. Dot stack of self dot sp minus 1. Yeah, which is the function instruction. Which is obviously wrong. Why? Why is my stack lopsided? Must have missed something. in the call expression, yeah, compile the arguments before call. Oh no. After. So that means only one of them failed, which is kind of weird. Oh well, all of the tests. One, 3, 6, 1. Yep, I expected this one. Not this one. Oh no, that's the argument count. Constant dot equal got dot constant survive. It's a guess, it's just a guess. I guess because there's two functions. Hang on, did I move the right one? Oh yeah, there's one more. I'm still not sure as to why that makes a difference. As in the order. What's happened to... I didn't even notice. Stream got restarted. Remove that. Oh, okay, I didn't see that. And this arguments in the VM. Yep. Can't find the function. That's sorted now. We calculate its position by decoding its operand, now subtracting it from the stack pointer. The -1 is because stack pointer is always pointing to the top. Okay, at least I don't get a segmentation fault. It's 4, but nil. Apparently VM can't find the arguments on the stack. That's a good point. Because it doesn't know which argument to get. Why it does that is not immediately visible and requires some working up of the stack trace. Method on 2 nil pointers, which is popped off the stack in order to add them together. That makes sense. That's why I was getting 34. Maybe. No, that's not why. Tries to find the arguments on the stack, but it gets nils instead. That at least something doesn't work is kind of what we expected, but then again, not really. Yeah, exactly, because I can see... Oh, hang on. Because I did notice something. Standard debug. Print any. Self.stack 0 to self.sp. So this is, which one was that? Here, this one. So 1 and 2. Symbol count is 2, integers 1 and 2. I mean, it's on the stack. Oh, get local. You have actually a couple of questions. The order of the arguments themselves. Okay, it'll be in the order which is defined. Okay. is where local bindings are supposed to be stored, and since we treat arguments as locals and want to retrieve them with get local instructions, that's exactly where they should be. That's the beauty behind the whole idea of treating arguments as locals. So why can't the VM find them? Because our stack pointer is too high. The way we initialize it together with base pointer when setting up a new frame is outdated. Remember that the base pointer has two purposes. Well, one is when you come back, like when you pop the function off the stack, you want it to return to the first one. First, it serves as a reset button and to get rid of the just executed function and everything the function left on the stack by setting, The second one is to serve as a reference for local bindings. That's a good point, actually. So the index of the local bindings have changed. Yep. Right before we execute a function, we set the base pointer to the current value of vim.sp. Yeah, which gives us the gap in the stack and slots on the stack which we can use to store and retrieve local bindings. Right. What makes our test fail is that before we execute the function, we already have things on the stack we want to use as locals, the arguments of the call. Yep. And we want to access them with the same formula we use for local bindings. Base pointer, yeah. Why? Really? I don't think so. Oh. Yeah, no, I've accounted for it. Maybe I missed something else. The problem is that when we now initialize a new frame, the stack looks like this. No, it doesn't. We add a frame. Oh, yes. Here. Okay, that makes sense. Totally missed that. That's why the whole thing gets messed up. Frame index plus equals 1. Actually, no. I did think of that too. Because we only need the base pointer, which is always the stack pointer before arguments were added. We set base pointer to the current value of aha, okay. After we push the arguments on the stack, that leads to base pointer plus the index of the local binding. We need to adjust the base pointer. The new and correct formula for base pointer is not much harder to understand. SP minus number of arguments. Yo. Honestly, I didn't know if I would have ever caught that. The question is that at this point, are the arguments on the stack? Yes, they are. Yeah, because it's function, argument, argument. Okay, yes, the base pointer is totally wrong. So I need to update this. Oh, actually I don't. New frame. Base pointer minus function Instructions dot. Yeah, fuck. It's come on, go back. Yeah. Or I could. No. I would have to update too many things. Okay, so that should fail a few things. Arcs out. Oh no. This is 0. This is the main. And add frame. Arcs count. Damn. So that was it? That was quite anticlimactic. Again? I didn't even think of that, really. That would have taken me a couple of days to figure it out. Compute base pointer. Call function. I didn't see the point of that. Yep, new frame is the only change. All of this should work. Damn, that's cool. So now I've just finished function implementation. We want an error but get none. I guess it would fail prior. Oh no, it won't. Oh, interesting. Yeah, I didn't think of that. Okay, this is just like some do I want to do this now? I don't know. Actually, this could fix the new frame. Hey, I was on the right track. bet I wasn't thinking of parameters. Ah, yes. I can assert the arguments are okay. Opcall to do check if argument count is as expected. Date object. Post update. Remove args count from new frame. Okay, that's for tomorrow. Function args now work. Okay, I guess that's it. Oh, it's nice. It's been a while since I've streamed for more than a couple of hours. I forgot what it feels like. Alright, have a good one, whatever's left of your day, and I shall see you maybe later today. I've been thinking of streaming in the evening too. I'm not sure. But yeah, anyways, thank you for hanging out. I'll see